Hello everyone, this is Naveen Kumar. Today my topic is about rocket and missile technology. In that topic, my my topic is about the solid rocket motor components. Here we are seeing that the diagram of a solid rocket motor. Here in this solid rocket motor, generally it consisting of a motor case, insulation, and nozzle, and igniter and propellant crane. Here, the function of motor casing is to resist the heat from the rocket engines. It will generally the casing it is made up of aluminum alloys and titanium and nickel. Whereas coming to the insulation is also acts as a resisting to the heat temperatures, and the function of nozzle is to convert the potential energy into the kinetic energy. Here, the heat exhaust gases which are coming out of the rocket motor, it will accelerate the flow, and the function of igniter is to ignite the fuel, which is fuel, solid grains which are in the chamber, and the propellant grains are the fuels which are mixed with the oxidizers, and the combination is called the propellant grain. Generally, the main components of a typical solid rocket motor engine, it consisting of propellant grain, and igniter, and motor casing, and thermal insulator, and nozzle, and thrust terminator. The motor casing that supports the propellant grain is made up of high strength and temperature resisting materials, and the casing is coated with the organic materials that not only acts as a thermal insulator but also offers a light bonding between the propellant grain and the combustion chamber. The casing of a rocket engine, generally it is made up of namely as a titanium and aluminum alloys, and that can be withstand high level of temperatures and stresses, particularly high pressure and temperatures. And the casing is coated with the organic materials that not only acts as a thermal insulator but also acts as a light bonding between the propellant grain and the combustion chamber. And the function of motor casing is to resist the temperature of gas temperature of the propellants. Even if the combustion is initiated successfully, the igniter cannot be turned off till it is burned out completely. Note that in a modern polypropellant rocket engines, a blown-out diaphragm is employed to terminate its operation even before even before complete burning of the entire grain. As a result, it is possible now to shut down the operation of uh, solid propellant rocket engines. And as we all know that it is not possible to throttling in the solid rocket motors when we compared with the liquid rocket motors and other rocket motors. And as a result, it is possible now to shut down the operation of SPREs, the high pressure and high temperature gas procedure due to the burning of the burning of the propellant in the combustion chamber is expanded through the CD nozzle to produce thrust. Here, the function of CD nozzle is to convert the potential energy into the kinetic energy with a high Mach number coming from the combustion chamber is to produce high Mach number, high velocity flow uh, to tackle the gravity effects that are faced by the rocket, and to get high escape velocity in the rocket engines. In recent times, the designers have started using fiber reinforced composite materials which are light than the metal casing, and the propellant grain of a particular shape is used to produce a certain type of thrust in a time profile. The propellant grains are typically solid rocket amounts of 85% of rocket engine's total mass. Here, the propellant grains are plays a major and vital role in the solid rocket motors. It consisting of nearly 80% of mass, whereas other components, which are 15% of solid rocket motors. The main components of a solid rocket motors are insulated with the nozzle and the igniters, and there are different types of igniters and the nozzle. And generally, the nozzles are types of convergent, divergent, and throat sections. Depends upon these parts. The nozzles may classified different in the solid rocket motors, whereas igniters are also classified depends upon the combustion chamber, propellant grains entering, and mixture of those fuels and depending upon the nozzle and depending upon the flight range and performance, the nozzles and the igniters are classified as there. And their main function is to ignite the propellant which is coming, which are in the propellant combustion chamber, whereas the nozzle function is to accelerate the flow, and the igniter is generally mounted upstream of the combustion chamber. The igniters are not located on downstream. It is because whenever the combustion chamber, which is the propellant chamber, uh, the igniter will ignite and it will expand through the nozzles. In order to initiate the combustion, the igniters are switched on to produce the hot gases with metal particles, which are virgin burning surface of a solid propellant grains and burning. Here the here the solid propellant or the particles which are coming in the form of grains. Grains continuously, as in the liquid propellant rocket motors. The fuel and oxidizer mixture comes in continuously by mixing the air fuel ratio. Whereas here in the combustion solid propellant rocket motors, here the propellant is comes as a solid parts continuously, and they will burn. And this is the solid motor casing, and this is the general diagram of a solid rocket motor.